although this is important, we have suffered a little bit in identifying those shocks. So in the oil market, there is a very rich literature, right? You can think about Baumeister Hamilton, Lutz Kilian, like Diego Kanzing. We have methods to see these things structurally, but less so for the rest of the commodities. This is for a number of reasons, but just to give you a summary, it's not very easy to get to the global quantities of the whole market for other commodities, and we're also less sure about the restrictions that govern the relationship of, say, wheat with GDP, unlike the case of oil. So we wanted to have an homogeneous method to talk about the whole market. So we thought that although maybe we cannot pick up the shocks, what we could do, if there are big shocks, then the news are going to write about it, right? So we tried to gather access, and this is the use of the funds and the grants to Dow Jones and Reuters articles. We started with 1 million, now we're at 8 million articles. So we are training the machine to basically read the text, and with some smart computer linguistics that are not automated at the first paper, we're trying to see which commodity is being discussed, whether we have a supply event or a demand event, and we also give it direction. We have a very large refinement step and an auditing step. So effectively, we're going to apply this toolkit to cut through the sources of confusion, all right? And we are going to describe all the markets. So my slides are not having the best of their days, but I think that there's going to be a lot of pictures from now. So there's going to be full compatibility between the tech and the PowerPoint. So I think we're going to be fine. So are the news talking about those things? First of all, we're scalping commodity-specific news. So this huge number is all about commodities. And these are only taken from Reuters back in 2003. And as you can see, not only the news are talking about commodities, you see different things than oil that would be usually covered. And there is a direct link in certain cases with inflation, right? So you see both instances have to do with the war in Ukraine, and you see information about gas and also about crops, and namely wheat. So effects, what do we find? I'm going to talk about two sets of finding. The first set of finding has to do with the first paper that links commodities to inflation. And we find that when we integrate those signals into inflation forecast, we are bringing down root mean square error by 20 to 30% with respect to the baseline model. This is a very big improvement. And it seems to hold not only when we have stable inflation, but under regimes of inflation that is increasing or decreasing. So we can show that effectively those signals, although they're not shocks, they move and walk and act like one. So we can compare the oil signals with the structural base method, and they look quite similar qualitatively and quantitatively. And this is going to be my second set of results that focus on the green transition. So with Alain and with Josh, what we do, we're trying to map a new geography of the big global exporters. So as we're moving from fossils to renewables and electrification, we're moving away from the oil and the gas and the coal to renewable energy that crucially depends on critical minerals, and also to electrification. And again, for electrification, we absolutely need those particular metals. So we are going to design the new map of trade flows that is going to have implications about the big superpowers, even about currencies, capital flows, financial flows. And I'm going to show you snapshots of these networks. And I'm also going to show you the big dominance of China in this network that is extremely central. So it basically either produces or processes 95% of this material. So it's not about tariffs, but if they switch off the production of these things and the dissemination of the rest of the world, the implication for US inflation are non-trivial. So effectively, very, very briefly, because I think I don't have much time, the way we do it, it's pretty manual. In the last paper, because we're trying to map the lithiums and the nickels, we actually moved to LLMs. But the very first technology of the paper is pretty manual. We use Python. We go through a large corpus of all these million articles that start back in 2000, and we train the computer to catch a word of the commodity in question. We're mapping 20 tradable commodities, and then we ask the computer to give us a contest of the most frequently used words, pretty much. And then we hand classify them into supply and demand buckets. So maybe these are a little bit my data sources from Reuters. So we cover energy, industrial metals, precious metals, grain, salts, and livestock. So the idea there is that if there's a big shock, the news are going to write about it, and the bigger the shock, the bigger the coverage. So I talked about the most popular words, I talked about the hand classification, and you see we're going very basic here, right? This is not black box at all. So for supply, we tell the computer to basically pick up stems of the word supply, produce, and output, right, for the general market, and for demand, consume, buy, and purchase. And when we zoom into particular commodities such as wheat, we enrich this with wheat-specific words such as crop, planting, farm, harvest. And for demand, flour, feed, and miller. So we do that for 20 commodities, and essentially to give this a little bit of direction, we have these formulas that are basically saying that if you have, say, wheat and crop, you look at the vicinity of the word in the sentence. So 4 words ahead, 4 words behind the word, if you have a directional word, there is a match. And then the supplies, they're going up or down. Same for demand. And then we summarize those signals, the supply increase, supply decrease, demand decrease, and we can make them nets, right? So net demand is a net demand increase minus decrease, and net supply is a net supply decrease minus increase. So either one or the other spikes, they're going to correspond to positive price pressure. That's the idea, is very simple. So these are noisy signals, right? This is how they look like for the case of crude oil. So I'm going to save you the reading. So the gray lighter shade is demand, net demand, the darker shade is supply. Demand is fairly pro-cyclical, so it collapses during the global financial crisis, 2001 crisis, COVID right there. And supply overwhelmingly for oil is governed by OPEC announcements that are unanticipated. Now, you can contrast it with the graph for wheat. So for wheat, supply events have to do with natural disasters or extreme weather conditions or droughts, as you would expect. Now, demand for wheat tends to be inelastic, obviously, but you have big demand swings when we have news that China is growing or pumping up the demand because it's a massive buyer. And then you see quite a bit of action around 2016. That's the trade war, and these are the agreements between US and China. And finally, you see the stockpiling of pasta we did during COVID at the onset, right? Precautionary demand. So this is, we can summarize everything into composite indicators. Again, you see a very large procyclicality for demand, and then supply is either OPEC or weather-related events for the whole commodities market. Now, what we do with the monetary policy paper, we are taking those objects and we are just enriching baseline forecasting models by putting net supply and net demand as additional predictors. Now, this makes a big difference, right? So essentially we have a very simple baseline model that you can see here. On the left-hand side, we have inflation growth, inflation lags, we have our net supply, net demand, and a big number of controls that you see here. These include the price changes, that we add them separately. Fed funds rate, information from the bond market, the stock market, exchange rates, and unemployment gap. So, effectively, what do we find? So in this table, you see the forecasting across 3 horizons, right? So with controls and without, for 1 year ahead, 6 months ahead, 3 months ahead. This is the root mean square prediction error of the baseline model. And then what you see, these are ratios of our improved models over the baseline. So basically, when you see from numbers 1 to 6, a number below 1 starred, we have a statistically significant improvement. Now, 1 to 6 are the different models. This is the way we're adding our indicators. So in the first 3 cases, we have the net supply, net demand, the 2 together. In the last 3, we disentangle them in supply increase, supply decrease. That seems to be a little bit weaker, right? Maybe because they're more sparse, potentially. Now, all in all, you can see an improvement between 20 and 30% in the specifications that include net demand. Supply on its own is not doing the job for us. And this is before COVID, without commodity prices, but largely similar picture, including commodity prices.
Yes, I mean.
Okay, great. And similar picture when we're rolling the COVID period. Again, with and without commodity prices. So, why is this happening? Why are we getting these sizable forecasting gains, and why is it coming essentially from demand? Our theory is the following. I'm plotting here together the net demand for the whole market, the first principal component of the individual demands of individual commodities, and the business cycle. So what is this telling us is this demand shock that we're reading is an aggregate demand shock that correlates very heavily with the business cycle. You can think of it as a boom or helicopter money. And what happens in this case, everybody is richer, everybody is buying a lot of everything. So essentially, an inflationary shock in one commodity tends to be inflationary for the rest of the commodities, and you see a very beautiful pass-through. All right? Now, what happens with supply, you can think of it as in the case of cocoa price increase. So we have an economy, and I'm a pastry chef, and effectively, the price of cocoa goes up, and I make chocolate cakes and banana breads. So I'm going to shift my production to banana breads because they're less sugar intensive. But at the same time, the price of sugar might go down because I'm going to tweak down my demand for sugar. So what you have, supply shocks are idiosyncratic, and you have different behavior between complementary and substitute goods. So essentially, you can have a temporary shock that does not transmit one-to-one to the CPI. So I have a whole section where I'm trying to convince you that these things look like shocks. So talking to the structural part that I'm going to skip. And I'm going to tell you that are pretty close, and you have to trust me on that. And they allow us, so to speak, to analyze the magnitudes between supply and demand. And indeed, we find that demand, if you look at it in a local projection setup, causes a more permanent and a bigger shift in inflation or different inflation baskets. So I also have goods here and services separately, and in the paper we have even more categories. Now this table, again, that has seen better days, what it tells you is that professional forecasters and households alike do not seem to pick up on those cues. All right, so if we draw this local projection with these indicators, this is not significant. So they do not, this information is there and it's accessible, but people tend to look at the price and they ignore the narrative when they're making predictions. So last bit, I talked about the new commodities for the green transition. So we have 13 metals and minerals. And as I said before, we're looking at these new trading patterns and the new challenges geopolitically. And these graphs maybe are gonna look better. So what we see, on the top map, you see the trade organization of these new metals, right? So you can see these hub and spoke systems. You can see the center is China. everything goes and passes by China. This is the old world of oil, and you can see multiple centers. Also in North America, the Gulf, Norway, Canada. Now, this is very concentrated. China was not always at the heart of those things. So before 2001, before the entry to WTO, and in particular, you can see in this graph in 1995, we always put China in the center of this network to compare the magnitudes. We have for copper and for lithium, the big exporter for both is Chile. So in 1995, Chile is exporting to the US, right? To Japan and to Germany or Canada. Now, fast forward to 2022, everybody is sending things to China. This is US, this is Japan, right? Just look at the size of the node that is gigantic. Look at what is happening to lithium. Again, China in 95, you have here Chile sending to Germany, to US sending to Japan. Lithium today, China gathering all the lithium of the world. Just to say that the forecast is that the demand for lithium is going to go up 30 times the next 5 years, not many years. Okay, so done. This is the last picture. If you switch off the supply of these metals, it matters for US inflation. Thank you.
Merci beaucoup. Est-ce qu'il y a des...
So I would think that whether it's supply or demand is time varying. So,
Yes.
So maybe in your data over the period you study, it's on average more demand shocks that have been better at forecasting inflation. But maybe if you look at the recent period, it's more supply shocks. You know?
Correct. One thing, indeed, one thing I skipped and I did not say is that the state of the art is that people would forecast with the prices until 85, but fail to do so after that point. So the relationship breaks down, and I think it is because indeed the prevalence of supply shocks after 85 is more often. Yeah, absolutely.
So I understood how you identified which articles were about wheat and which were about supply and demand, but how do you identify whether they're talking about an increase in demand or a decrease?
So,
as in, do you have an additional bucket of positive and negative words?
I do.
Okay.
So in the first version, that is like we can understand, like the computer runs through the corpus, say you're interested in wheat. So it identifies a sentence within the article that talks about wheat. And then it looks at the dictionary of wheat. So say the word crop is there. So it focuses on the word crop, and then it inspects 4 words after, 4 words before, for a directional word. So and these directional words are standard from textual analysis. We take it from computer science, is anything you would expect. Increase, peak, trough, decrease, down, all those things. Yeah.
And you have a fixed set of words for each asset?
We do. I showed you that the dictionaries are pretty, Doric in a sense. They're small, and the reason for this is that we wanted to focus on accuracy of signals over quantity.
Because if I remember well, when I saw your slide on your dictionary, I'm surprised you didn't choose peak for oil.
Peak is always on the directional dictionary.
Okay.
Right, so it's always there.
Okay.
It will be coupled, right? But certain things such as imports, the way we read it can be ambiguous, say for supply and demand, and these are why the target words are fixed, because we have audited them to death, and they are accurate, right? They make no mistakes.
Other questions? D'autres questions? D'applaudir nos 2 premières interventions.